Bond polarity arises from the unequal sharing of electrons within a covalent bond. This can be identified by looking at the difference in electronegativity values of the two atoms involved. So on the screen here you can see I have an H2 molecule, and this is what's known as an electron density map. Basically it draws a big blob around either of the atoms, showing where the electron density is found. Right, so the darker the blob, the more electrons are found on a particular atom. As you can see from this diagram, that because both atoms involved in this molecule are hydrogen, the electrons that are in that covalent bond, so the solid line you would draw between the hydrogens, the electrons don't spend any more time around one hydrogen atom than the other. Okay, they're equally drawn to both of them, and they're nice and shared. So you can see, and again, it's cartoon-like, but the blob drawn around the two hydrogen atoms is of the same size, it's of the same shape, it's perfectly symmetrical. So what this amounts to is this is equal sharing of electrons between the two atoms. We would call this a non-polar bond. All right, now contrary to this is what we would call a polar bond. So in a second here we'll see on the screen a hydrogen fluoride molecule. This is HF, and you can see immediately from the picture of electron density that it's not symmetrical and it's much darker around the fluorine. This arises because as you can see at the bottom of the picture there, fluorine has an electronegativity value of 4, while hydrogen has a value of 2.1. The electrons are drawn much more heavily towards the fluorine. Right, so the sharing is not equal between hydrogen and fluorine. We would describe this as being a polar bond because the electrons are actually found in one region of this bond much more so than the other. Again, the cartoon blob cloud-like version of this shows represented pictorially, and it shows much more electron density near fluorine than hydrogen. But again, we can pick this out just by looking at the electronegativity values. We find that fluorine is much more electronegative than hydrogen, so we would say that this bond is polar towards fluorine. The extra piece of information we can add to the HF diagram is one that indicates the polarity of the bond. So what we do is we draw an arrow pointing towards the more electronegative atom. So fluorine's value is 4, while hydrogen is 2.1. And then we use these funny little Greek lowercase d's, delta positive and delta negative, to indicate the more positive and negative atoms in the bond.